Hello everyone. I made this recording to share the results of an AI experiment I worked, during some of my personal time. And the goal of this experiment was to evaluate how AI could be used to extract and analyze complex product information models. Basically, provide a digital thread analysis powered by AI. So in this recording, I quickly outlined the technical challenges. I will walk through the approach I've taken and demonstrate what the system is capable of doing at the moment. And I believe it shows strong potential. All right, so there are a few reasons why traditional searches, navigation, and analytic methods are often not sufficient when you really face this large information model. And the first one is scale, right? Because even so-called simpler products like smartphones can easily involve tens of thousands, sometimes millions of interrelated engineering artifacts. Okay. Then the next reason is well, these artifacts are linked together, and it could be then potentially millions of semantic relationships. And then with that, it's very difficult for engineers to get meaningful answers using traditional navigation or queries. And queries could be incremental. You can try to refine results, but this is very slow and most of the time painful to go through such refinement of queries. So and then let's not forget, the whole idea is we're gonna actually interrogate an information model using natural language, and the challenge there is engineers may ask practically an infinite number of questions on their products. And because that, if you have worked with large language models, you have probably noticed that such variety of wording and phrasing also create just as many opportunities for the AI to go off track and return irrelevant answers and hallucinate. So what are we looking at? Well, this slide is basically showing two examples of typical engineering questions we are interested in. So let's go through them. So the first one is find all high priority requirements with at least one low effectiveness test case and propose additional tests to ensure complete requirement verification coverage. Okay, that's a multifaceted question, right? You need first to retrieve the data, you need to analyze the level of priority and effectiveness of test cases and requirements, and then finally you need to figure out can you improve the coverage, is the coverage good, etc. The next question, interesting as well, identify all high-risk requirements not verified by high effectiveness test and suggest improvements to close ISO 26262 certification gaps. So again, matter of first of all finding the right data, but then try to analyze this data against regulations like ISO 26262 and try to improve the test coverage. Okay. So these are two examples of engineering questions that traditional system will struggle. Against searches and query system. And this is where AI, especially when guided by intent and structure, can make a big difference. Okay, so given this virtually unlimited number of questions engineer can ask, and the corresponding risk of LLMs drifting, hallucinating, I really needed to find a way to constrain ambiguity and improve consistency. And to do that, my approach has been to formalize questions into structured query intent patterns grouped by engineering purposes, like you see on that table, traceability, completeness, impact, risk, and so on. And this approach really helped me improving the overall performance of the system, as instead of constraining what the AI model can answer, it actually enabled me to expand the scope of the model capability by aligning basically language understanding with domain semantics. So, reducing the chances of misinterpretation. So all that formalization plays in practice. So as you see there at the beginning, so one question is asked by the user. The system identifies the intent by matching it to one of the structured patterns. like completeness, impact, etc. And then it builds a targeted prompt, and then it's basically going to execute or create a query first, execute a query, save the results, and then finally, in order to answer accurately to the question, the model is going to analyze and potentially summarize. And so this is illustrating the simplest and most, I would say, direct execution path, because the system actually we implemented can do additional things like, handle general knowledge questions, like what's the speed of light, which has nothing to do with the data in the database. It can reuse prior results for follow-up question, and it can handle situation like where no query is needed, and question could directly be answered from the data we save in the context. All right, so to support that, not a big surprise, we implemented a multi-agent framework. So let's start with the first agent, the planner. The planner interprets the user intent and first checks whether the question can be answered directly using web search, prior context, or general LLM knowledge. And if not, it's going to delegate the task to the programmer agent with a structured instruction describing what data needs to be extracted from the information model. With that, the programmer basically translates the instruction from the planner into an executable query, validate the syntax of the query, execute the query, and save the results. And then finally, the analyst on the far right basically passes the results, and either is going to summarize the directly or runs additional reasoning using the LLM as needed. And then it gets that all together to respond to the user with a clear natural language explanation responding to the question. So before jumping into the demo, I want to quickly introduce the data set behind it. So it contains about 50,000 objects, interrelated, and you will see objects like requirements, test cases, parts, functions, design components, and these objects are basically mapped semantically with relationships like verify by, realize by, compose of, and implement. So it's not a super huge information model by industry standards, but I think it's complex enough and to realistically evaluate how well AI can extract insights and basically address engineering questions. So that's how it looks like as a graph. So right there, there's a zoom on this area of the graph. This is the entire graph right there. And now we are zooming in on one portion. I think looking at this, you can immediately feel the density and complexity. So that's not something you can meaningfully navigate and filter manually. All right, so for this demo, I split my screen in two. On the left side, there's a bunch of questions we will use to show what the system is capable of doing. And then on the right side, I got my web app, very typical kind of UI, right, where you type a question and then you get an answer from the AI. So it's a prompt. And before I start the demo, just want to say a few words on the models I'm using, the LLM model. So remember, 3 agents, the planner, the programmer, and the analyst. So for the planner and the programmer, I'm using GPT-4.1 Mini, a pretty cheap model. And for the analyst, I'm using something a bit more expensive. It's GPT-03. Okay. And O3 has reasoning capabilities, and that's why, for the analyst, it's quite interesting. Okay, so then on the left side, so I did prepare a number of questions. Again, they're organized, following these ideas of patterns. It's called categories in this Word document. I'm not going to go through all these questions. We're not going to ask all these questions you will see on the document to the system, but we'll try to have a panel of questions going through, so it gives you a good idea of what the system is capable of doing now. All right, let's start with some simple questions, related to understanding the meta model of the database, the information model. Can the system actually tell me how many objects are in the database. And you see some of this debug information. We see the agents that are being called and in which sequence. That's always interesting. Right now we are at the end. Okay, that's the response from the system. And yes, this is the right response. Then I can ask as well, what do you know about the relationships into the info model? So we understand that as well. And that's quite important for any more sophisticated queries. All right, so it's identified the 4 type of relationships. So let's go to something maybe a bit different. So the next category relates to finding objects related to others. Very typical question. Find me all the test cases related to requirement. Creating the query, hopefully the right query, and then at the end, analyst investigating the data extracted from the information model. So what we're going to see in that case, because I see the analyst agent being involved, it's not just going to list the requirements, but it's going to provide a summary. And okay, from 26 test cases, okay, there's a quick description, and then it's saying, that each test case already confirmed upstream to man, and etc. So, from there, I can ask a follow-up question. Maybe something, let's see, which type of requirements is that? Compliance, functions. Okay, safety, interesting. How will you improve the test cases to increase coverage related to safety, right? ISO 26262, that's a standard in automotive. So let's see what it can do for me. So you see that using the same data. So the system detected that it does not need to extract additional data. It's not going to delegate to the programmer. Just looking at the data that we're extracting, it's going to try to figure out how you can improve the coverage with maybe additional test cases or improving the test cases. All right, here you go. Okay, let's go to the top. Okay, the current suite already addressed ISO 26262 in multiple places. However, coverage is concentrated on verification of compliance. ISO 262 demands evidence across entire safety lifecycle. All right, providing some insight where the coverage is not too good. No explicit test for certain area. Okay, this one will fault injection negative scenario. Oh, that's bad. ASIL tailoring is absent. Okay. Okay, the risk, and then it goes through mitigation and improvement recommendation. So we're not gonna read all that stuff, right? But then as you can see, started I'm putting some better test cases and enhancements for test cases for the question what I was asking, which is to improve coverage for ISO 26262. All right, so that one was interesting. Let's see if I'm not gonna. So maybe we're gonna skip this one. Let's try this one. That's an interesting type of question as well. For instance, in that case, trying to understand if I have any low functionality architectural elements in my concept design. So it's going to identify eventually these design components that have maybe less than 10 functions. Again, that's an example of a question. And then in that case, as you can see, I was just asking a list, so it's not going to call the expensive GPT-03, okay, and just going to provide me the list. Okay, so let's go to the next one, next category. Okay, multi-op. Okay, and if you remember the information model, the meta model was requirements being verified by test cases, then it goes requirement to design components to part and function. So What was interesting to figure out when programming this AI was to get him understanding the multi-levels of traceability. So for instance, if I ask a question like that, well, not this one is a direct link, maybe this one. So, basically parts are 2 levels above from a relationship model, right? And he needs to figure out how to traverse the relationship model to get me the parts related to requirements. All right, so the agent is formulating a request to the programmer. Programmer creates a query and is going to execute the query in few seconds. There we go. So that's the list of requirements, actually quite a lot of requirements. Okay, so that was an example of what I call multi-op, so being able to traverse the relationship model to get directly to the data that are relevant from the question. Okay, let's go to the next category. Keywords filter, yeah, quite useful. Interested by all test cases related to emissions, fuel economy. Yeah, because I want to focus on that. Maybe I want to do some improvements in this area. Actually, let's see if we get the test cases. Maybe we're going to ask some follow-up questions. Emissions, fuel economy, obviously a regulated area in automotive. Okay, so it found 20 test cases. So let's ask a follow-up question. Again, maybe we ask to improve these test cases or create new test cases. Or let's ask new test cases. Can you think of new test cases to increase compliance to regulation for emissions? All right, let's see what it can do. No, I don't know if it's going to actually create a new query or searching the web. That's a bad move. Okay, wasn't good. It should not search the web. It should basically use the existing data and try to figure out if we can add test cases. Let me, maybe insist and ask the system to try again. Okay, yeah, cannot find out. All right, so that one wasn't a success. So let's try another one. Let's see. Okay, so maybe this one finds a concern with emission. Yeah, let's try this one. Find design components that are related to emissions. Okay, executing the query, and there we go. So let's try again the follow-up question. So what can we ask? Maybe we're going to ask, can you summarize the role of these components together? I have a spell check, but he's going to understand. Smart enough. All right, good. No delegation, using the same data. It's exactly what we want. So it was a bit, it's still a bit of a challenge to actually get the system to understand the differences between a follow-up question, a question that requires a new query, a general question, a web search. So that's, from time to time I got these little issues as you saw before. But anyway, in that case, it was working fine. So it's, basically doing a summary, basically providing insights, categorizing actually the design components by functional clusters. Quite interesting. Always actually that's the way I program the system. I'm always interested by risk mitigation, just providing some warnings to the engineer. And then, yeah, and if you start telling me problems, you need to propose me some next steps. So that's the way I've been wiring, the model. So I get this kind of, typical answer all the time. All right, so let's go to maybe some more examples. Oh yeah, that one is quite interesting. If you are, in charge of system engineering, one thing you don't want is to get, objects not mapped to anything. So let's, as a system, are there orphan objects? And by the way, I teach the system what an orphan object is, right? It's not necessarily obvious. Maybe it's obvious for the human, but for the computer, what does it mean? Well, in that case, it means objects not mapped to anything. And yeah, it did find 37 objects, a bunch of test cases, a function and a part. Okay. Another very typical questions. What you don't want is to get requirements not verified. So same thing. What does it mean not verify? So I had to teach the system that not verify means in that case requirements that have no test cases associated to them. So normally it's going to be smart enough to put together the right query and analyzing the data to find these requirements without test cases. All right, quite a lot, 61. Okay. I think we did that a bit before. So now, not only I want to retrieve data, I want to get changes or get proposal for changes. Like in that case, this requirement. What can we do to really improve its verification coverage? So that should be a new query, definitively. And see, again, the problem. It does not understand actually that I need a new query. So let me, as I did before, and maybe I'm going to help it a bit. Try again, creating a new query. Come on. There we go. So now I have to explain him a bit. So that's interesting again, ambiguities in the questions. How do you address that? So it's not always easy. So and then it does not provide me the right answer either. Breakdown test cases. Okay. All right, so let's move on. Let's go to another category. As you see, it's far to be perfect. Still have some challenges. So going to the next category, impact analysis and propagation. Okay, find all design components, functions, and parts impacted by a requirement change. Yeah, well, typical impact analysis question. All right, and it's a very long list, apparently. Design components, part, functions, etc. So something I want you to note on that, because this is not very well formatted, and why? It's basically because actually there's a too long list, and I got a safety net to not, explode the cost on the LLM, which is, limiting. I think for in that case, it's maybe 10,000 tokens, something like that. And basically not calling the LLM to process and analyze the data. Yeah. Total objects found 4,000, and you see this message too large for the model context window, so just returning a table. Okay. And obviously I can fix that by augmenting the number of max tokens, but in that case we reach out the limit. All right, so let's see what else. Retrieve all document pages. Okay, well, that's an interesting one. So again, in that case, um, not only retrieving impacted objects, but also asking the same question, the follow-up question, which is to summarize the risk of making such a change. Okay, so let's see. Found 18 requirements. Okay, and starting telling me the focus of these requirements. NVH, good. Giving a list of requirements and then answering my question. What's the risk of changing these requirements? So increase noise exposure, degraded active noise cancellation performance, NVH regression, pedestrian alert compliance gaps. Well, I have no idea what it is. Simulated XTR, so okay, etc. And then again, as I said before, where this pattern, what mitigations are you proposing, some additional insight, and final recommendation. Okay, so that's pretty interesting. Let's go to the next category. Effectiveness and quality evaluation. So that's that's an interesting area as well. So let's try this one. Find requirements with high priority and at least one validating test cases with low effectiveness. So again, probably something you don't want, right? High priority requirements should have highly efficient test cases. Okay, let's try that. And then again, it's a multi-side question, right? Not only I'm asking to find, understand, first of all, what is high priority, low effectiveness, because these things are actually attributes to the objects, like, priority 5, 3, 2. So I had to teach the model as well to understand what this number means. And then the second part of the question is, well, you need to propose me some improvements for the testing, because I can't just leave these things like that with low effectiveness test cases for high priority requirements. All right, here we go. Summary. Okay, this requirement, dynamic tracking of small objects. Okay. By single validated test cases, which has an effectiveness of 0.6. So it actually found only one test case with a low effectiveness for a requirement which is high priority. Okay, I did not remember I put the data set that way. Anyway, going through risk, and then as I asked the system, propose me some testing improvements. So there's a list of testing improvements, recommendations, decompose the requirements, upgrade the existing test case to incorporate the new KPIs above, and then next steps. All right, quite interesting. Okay, this one is similar question, so let's go to the next category: traceability, risk, and compliance analysis. So it starts to be sophisticated, and let's try this one. And yeah, this one is definitively multifaceted. So if you need to comply for ISO 26262 in that example, and this is true for many regulations, you got to have a specific traceability between objects. So for instance, in that case, 26262 mandate that the requirements are mapped to the realization of the requirements and their testing. So requirements, design component, function, test case. And you need to be able to prove that any requirements in your system have this type of traceability. Okay. All right, so let's see. All right, let's look at that. Scrolling up. Oh, I see something wrong. All right, so total of 53 high-risk safety-related requirements were identified. Okay. 98.1% show complete ISO 26262 compliant traceability. So, but found a guy that has not this traceability, so this requirement. That's interesting. So there's a list of other requirements complying to the traceability, and then this guy is not. Okay, then obviously next steps are going to be to figure out how do you map the requirements to design component, function, and test case. Okay, that's pretty cool. Again, in this area of regulation, maybe we're going to try something else. So the previous one was ISO 26262, functional safety regulation in automotive. In system engineering, there's a body there called INCOSE, which also propose best practices for defining, for instance, requirements. So I'm going to ask the system to find requirements related to sustainability, and then verify they are properly written based on INCOSE standards. And then if not, then I'm asking the system to propose improvements so I do a better job related to INCOSE best practices are telling us. Okay, let's see, let's go to the top. Okay, found 3 sustainability requirements. Okay, they are tag compliant with INCOSE standard. Risk mitigations. Then it's making proposal to refine the requirements against the INCOSE best practices. Okay. That's mostly the way you write requirements. That's what INCOSE is providing mostly with their rules. Okay, so that's the one. Let's go to the next category. Requirement coverage and test case effectiveness. Let's try this one. So retrieve all test cases for a given requirement, and then tell me if there's any test cases contradicting actually the description of the requirement to be verified, and if yes, maybe suggest some clarification. All right, let's go to the top. Okay, so, oops, not that one, sorry. Went too far to the top. Okay, retrieve all test cases potentially contradicting this requirement. So to the return contradiction. Oh, so we did find some with contradiction, but I don't see them in the list. They must be manufactured using test cases. Oh, that's the list of contradicting test cases. Wow, that's interesting. A bit surprising. I guess this will merit a bit more investigation. Insight. 20 of the 26 test cases focus on safety, cybersecurity, partial alignment, but incomplete. Oh, that's interesting. Okay. Maybe you try this one for the top. No, we don't try this one. So let's go to the next category, which I think is the latest category. So semantic and reasoning capabilities. Again, these are about multifaceted questions. Like this one. Analyze if any test cases that have an expected outcome that seem to be inconsistent with the intent of requirements they are validating. That's quite an advanced question, right? So let's see what it can find out. All right, let's scroll to the top. Okay, so all 16 test cases reference requirement and concentrate on system level integration with strict communication latency goals. Most expectations are coherent, however, two clusters show contradictory latency targets for essentially the same communication domain. Wow, that's interesting. So basically went through the test cases, expected declared outcome, and why it may conflict with the requirements, apparent intent. Okay, that's quite sophisticated. Insight, uncertainties, that's something new. I never seen that before. And then again, mitigation recommendations. All right, so that's very interesting answer on a very interesting and sophisticated question. Now, obviously, that thing is multilingual, so that's now a question in French, because I can read French, and basically it asks for analyzing, listing all the requirements not being tested, and then propose strategy of validations. All right, so ask in French. I'm going to get a response in French. And that's quite interesting, and the reason I want to show this example, it's, everybody knows that LLM can speak multi-languages, but I guess for engineering that's interesting too, because I can collaborate with people across the globe, and I don't have to ask them to speak the same language as me, and we can still communicate and maybe analyze the same information model while speaking different languages. Yep. And so as expected, response comes in French. Okay. And I'm sure I can have a follow-up question to write a report for my colleague in Japan and write it in Japanese, and that will work perfectly. All right, so maybe a couple more questions for this demo. That one is interesting too. Analyze why might requirement XYZ still be failing test, even though it's linked to several validation test cases. So is there a risk that we're not going to actually validate completely and accurately these requirements? What do you propose? All right, let's look at the response. Okay, requirements aggregates a broad set of predictive capabilities, braking, engine, start logic, navigation, driven energy, etc. Every link test demands super or equal to 90% prediction accuracy. Even one miss on any scenario subsystem, okay, and then goes through the key risk and what could be the consequences of this risk. Additional insights, and then some more detailed mitigation. So basically proposing how can we improve the testing so we avoid this risk. Next steps. That's quite complete. It's good. And of course, it will take a while to really analyze all this data, but that's the kind of very detailed response you get. So maybe let's try with the last question for this demo. So this one is, maybe a follow-up question. And I'm asking, the system to summarize for my project lead, explaining which requirements are risky and unvalidated and why we should address them to now our next sprint. All right. And again, quite of a very detailed answer. So basically scoring the risk, identifying the risk, what if the risk is not addressed, what is the ROI impacted into, well, in that case, the automotive system. Potentially hazard is going to cause, and there's something very serious there. You don't want to let that go. So thanks to the AI to have identified these things, mitigations, insight, next step. All right. So that's the end of the demo. Have you seen? Have you saw it? Got a couple of wrong answers, but generally it's quite capable across all these categories and patterns. So to conclude on this experiment, I have a few takeaways. The first one is, AI can definitively answer complex engineering questions, and with some good level of consistency, especially if you ground, free-form language in structured intent-driven patterns, like which is the core of our approach. Next, formalizing these patterns has been improving a lot, accuracy and coverage, and basically reducing ambiguity. Multi-agent, in that case, quite important because you can have separation of concerns, between planning, querying, and reasoning, and so the free agents we have been implementing. And as we have seen, still some challenges, especially in terms of distinguishing between different type of questions. Is it actually a matter of general knowledge? Is it a follow-up question? Does it require new structured queries? In terms of next step, I think there are several directions I can think about where we can expand and make the system stronger. First, I think there's an idea there where we could explore or put in place dynamic prompt adaptation using reinforcement learning, which is could help us to continuously refine using futures example, but then kind of dynamically updating the futures so you can improve the system. The second one is pattern coverage. I'm sure we can figure out questions where the pattern is going to struggle to categorize it. So that's something we can actually think about as well. Support deeper analysis, where we could enhance ALM reasoning with a chain of thought, scaffolding. I think that's something people practice in AI, and I think this one could help us as well. Longer conversations, follow-up handling will certainly benefit from memory augmented agents or smarter context caching. I can also envision, in this space, tighter integration with system modeling, such as SysML v2 models and engineering ontology, so to ground AI in formal semantics and model-based reasoning. And maybe one last point, improving the generation of data queries with retrieval augmented decoding or specialized agent could make query translation more robust and accurate. All right, so if you made it all the way to this slide, then thanks for sticking with me. I hope you enjoyed the topic and maybe learned something useful or inspiring along the way. Thank you.